Problem defined. Build a self-driving robot that navigates an obstacle course consisting of a starting area, a hump, a slope, and a wall. This robot would be deployed for disaster relief. Our group used the method of collaborative sketching to generate innovative and diverse ideas, each member working independently to sketch their proposed solution to the defined design challenge. The sketch is then passed on to the next member, who may then add, modify, or delete aspects of the design solution. This continues until every member has had the opportunity to revise every sketch. At the end of our C-Sketch process, our group generated 5 innovative and unique ideas through the collaborative efforts of every team member. Idea A is a monster truck robot. This robot has big wheels to allow it to traverse harsh terrain. It also has LEDs which light up in the dark areas, providing visibility to the rescue operations. It also has a friendly and familiar Cybertruck design with a huge storage area to transport supplies and humans. Idea B is a robot car modeled after a spider. Having 8 legs provides this robot with the stability and dexterity required to traverse through undulating terrain. The 8 legs of this robot also enables it to bear more weight, allowing it to carry more supplies and humans. The spider-like design is also friendly and familiar. Idea C is a robot car modeled after a tank. The track wheels allow it to be able to traverse harsh terrains as well as the ability to bear heavy loads, meaning it can carry more humans and supplies. Idea D is an amphibious robot car. The wheels were inspired by the design of a watermill and allows it to pedal through water, making it able to travel both through land and water. Our 5th idea is a yo-yo robot car. It is nimble and can traverse undulating terrain easily. Each wheel has its own motor, allowing it to change direction. It also has multi-purpose arms to carry supplies, remove debris, and transport survivors. Our group then voted on the ideas based on the following criteria: most rational, most delightful, most unexpected. As seen from the final score, ideas A, B, and E were evenly tied, and our group decided to proceed with idea A as it is the easiest to implement.
Prototype 1 was unable to clear the obstacles because the bottom chassis was too low. Collisions with obstacles would occur. Hence, we concluded we need to make changes to the chassis and increase the distance between the wheels and the axle. We removed the bottom acrylic chassis and made modifications to the top acrylic board.
In Prototype 2, the motors were getting in the way over the obstacle. This caused our vehicle to suspend in the air and become stationary. To solve this problem, we increased the diameter of the wheels by using layers of anti-slip mat. This could increase the clearance between the motors and the ground. Our robot would still occasionally fail to clear the second obstacle. To tackle this, we used a higher gear ratio gearbox in order to increase the torque. We also changed our motor power source from 2 9-volt batteries to 12 1.5-volt batteries in series to provide more power. Another difficulty is that the vehicle would stop earlier than usual due to inaccuracies of the ultrasonic sensor readings. This is because the reflection of the ultrasonic sound wave is deflected as it reaches the ramp at an angle. We solved this problem by increasing the distance reading range in our Arduino code to account for the errors. After many trials, we were finally ready to test our robot. Our final prototype was a consolidation of all the previous iterations and improvements made, thus enabling us to clear the course with flying colours. We added some extra features to our robot. The vehicle's final design tapered body was inspired by Elon Musk's Cybertruck. This clean and sleek design is meant to provide civilians with a sense of calm when they see our rescue vehicle. We included 2 LED lights in the front of our vehicle which would light up when it detects obstacles. With the help of our LDR sensor, we added some light strips at the side of our vehicle that would automatically light up when the luminosity of the environment is low. This ability could alert civilians that rescue has arrived during disaster relief. In addition, we also added a HC05 Bluetooth module to our prototype, and that enabled us to control the vehicle remotely. Using MIT App Inventor, we had developed a custom mobile phone application that acts as a remote controller. A remotely manned vehicle would be very useful in overcoming complex, unexpected situations that require flexibility during disaster relief.